Okay, so we are July 20th today. Um, so you've got quiz number 6 that is due. It is a week from now that you will be done the course, which is fantastic. So you really just got a home stretch. And so we're looking at multiplication of independent events and then permutation and combinations. So you've got your quiz here. And so you've got your multiplication of independent events. So consider an experiment in which you first roll a 6-sided die and then flip a coin. And so my allergies are driving me bananas today. Draw. Okay. So you've got your die that you're going to roll first. After that, you're going to have the coin, which is heads or tail, coins, and your outcome. Okay. So your dice only has, or your die only has 6 sides. So your outcomes are those numbers. And then for each roll that you've got heads and tails. Wow. Let's go back here. So undo. There you go. Much better. Heads and then tails. This will be heads and tails. And so it keeps going like that. Obviously, you'll be able to do it a little bit better. Heads, tails. Okay. And so your outcome here is that you'll have 1 and heads. So that's this guy. And then you've got 1 and tails. And so you'll keep going like that. So you'll have 2 2s, heads, tails, 2 3s, heads, tails, 2 4s, heads, tails. And it keeps going. It's a little repetitive. And 6 heads and 6 tails. Okay. So those are your possible outcomes. So if you count them all, you've got 12 different outcomes that you can have. Boo-ba-doo-boo. Okay. So instead of erasing everything, I'm just going to erase this part. And so that way I can answer B and we can still look at the outcomes, which will be a lot easier for you to visualize. So it's asking us, what is the probability of tossing tails and rolling even? So I'm going to use a different color for this guy. Okay, so tails, that means that this guy's out. And you can scratch out the ones that you've got. Okay, so we need the tails. We also need an even number. So we can cross out that, and that. So that leaves us with our number of tails that are even is equal to our number of tails, or the possibility of tails even is our number of tails that are even, and then our total number. Okay, so we can count that there are 3 possibilities. And then our total amount of outcomes was 12 that we counted. And so that can be simplified to 1/4. And that's it. So that is the answer for B. So I'm going to be clearing this so I can scroll down. So just to remember that this is the formula that you would use to find the probability. So that's what we looked at. So the probability of getting tails and even is equal to the number of tails and even possibilities, and then the total amount. So we've got part 1, which is the multiplicative principle of counting ordered pairs. So if the outcome for each experiment, such as flipping coins and rolling dice, has no influence on the outcome of any other experiment, we can use ordered pairs to write the outcome. So ordered pairs are used for independent events. So the total number of outcomes is the product of the possible outcomes at each step in the sequence. We can count these ordered pairs where n of a b, here, is equal to n of a times n of b. So another way to think about it is if one event can occur in m ways, a second event can occur in n ways. The number of ways the two events can occur in sequence is m times n. Okay, so we're going to do some examples. Obviously, that was a lot of mumbo jumbo that might not make sense, or you can't visualize it. So I'm going to clear this and we're going to take a look at the examples. Okay, so example 2, how many outcomes are possible in the die roll coin toss experiment? Okay, so we are looking at n. So how many times we can roll the dice in coin toss is going to be the number of times you can roll the die times the number of times or possibilities for, wow, coin toss. Okay, so our number of die is a 6-sided die, so there are 6 possibilities, and for your coin toss you've got heads or tails, so it's 2, and so that would be 12. So that is to find the number of outcomes. That is not to find what we were looking for in the first one, which is the probability of getting this and that. Okay, so how many outcomes are possible in an experiment where you draw a random card from a standard deck, then roll a 6-sided dice? Okay, so that would be our number of card die is equal to the number of cards times number of die. And so a stack of cards has 52, and then our die has 6 sides. So if you throw that into the calculator, or you're really good with multiplication, it gives you 312. So I'm clearing this. We'll do a few more examples, I believe. Yeah. Okay, so keep in mind that this is for ordered pairs. And so you're going to the school dance tonight and can't decide what to wear. You've narrowed it down to 4 pairs of pants, 6 shirts, and 2 pairs of shoes. So instead of doing that whole tree table shenanigans that would take a long time, you're going to do n of outfits. So the number of outfits is equal to the number of pants times the number of shirts times the number of shoes. Okay, so it's relatively easy in my opinion. So we've got 4 pairs of pants, 6 shirts, and 2 pairs of shoes, and that gives you a whopping 48. Okay, so I'm clearing this and we're going to look at independent events. So consider the experiment where you roll a 6-sided die, then flip a coin. What is the possibility of tossing the coin and getting tails if you know in advance that the die will show an even number? Okay, so we've got P of tails and even. is what we are looking for. Okay, so tails and an even number is equal to the number of tails that are even over the number of evens. Okay, so we know that we have 3 that are tails and evens, and 6 of them will be even. And so that can be reduced to 1/2. Okay, and so we're going to look at number 2 here. What is the probability of getting tails when you flip a coin? Da, 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 da. So that's relatively easy. There are 2 sides to the coin, and one of those is tails. That's it. Easy peasy. Okay, so make a conclusion about your answers to 1 and 2. So I'm going to type this out. Okay, so where am I here? P of tails that are even is equal to P of even because they are independent events. So the general rule is if A and B are independent events, then A is equal to B. And that's where we see this here. So yeah, so our number of possibilities or probability of tails and even is equal to our amount of even. So that saves you a bit of time remembering this rule. So just keep that in mind, maybe put like a star or whatnot. So we've got part 3, which is the principle for probabilities of independent events. So if A and B are independent events, then I'm not going to draw this or write it down. Nope. Okay, so then P, A, and B is equal to times P of B. Okay, so in the roll, our die roll and coin toss experiment use the multiplicative law for probabilities of independent events to determine the probability of rolling an even number and then flipping tails. Okay, so here we've got even tails is equal to the probability of even times the probability, probability of tails. Okay, so the probability of it being even is 1/2, and the probability of it being tails is 1/2, and so that gives us 1/4. Okay, and that was our original answer that we had gotten. So I'm clearing this. So note that sequences of independent events can be written as ordered pairs. And so here is our equation. So example 6, a coin is tossed and a die is rolled. Find the probability of flipping a heads and rolling a 6. Okay, so we've got probability of heads and a 6. So probability of heads times the probability of a 6, which looks like a B when I'm writing this. So the probability of getting heads is 1/2, whereas probability of getting a 6 is 1/6, which will give us 1/12 as our probability. So I'm clearing this. So find the probability that Crosby gets a point in a game of is 85%. So find the probability that he gets a point in 3 consecutive games. Okay, so this is going to be super repetitive. So it'll be point is equal to P of point. I'm just going to write it like that, times P of point like that, and times P of point. Okay, and so percentage, obviously you got to put it into decimal when you're doing it. So it's 0.85 times 0.85 times 0.85, which will give you 61.4% chance. Find the probability that he gets no points in 3 consecutive games. So I'm not writing that again. It's the exact same thing. And so this is going to be the chance that he doesn't get a point is the remainder of this. So if you do 100%, take away 85, it'll be 15%. So you're doing times 0.15 times 0.15. Okay. Which is equal to 0.3%. And we've got the last question here. So I'm clearing that. Find the probability that he gets a point in at least one of the 3 games. The phrase at least means one or more. The complement to the event, at least one, is the event none. So the probability of point in at least one game . Well, there's an E there. Okay. 1 minus the possibility of point in no games. So it'll be 1 minus 0.003. So that's from B, which is equal to 99.7% chance that he will get a point at least once in the 3 games. Okay, so hopefully that makes a lot of sense. It is quite a long package. Just keep in mind this stuff is a little repetitive. So if you find that it's too much, just skip some of the independent questions. If you find you're doing great without them, I'm not marking them. It's really just for attendance. All I'm marking is the quizzes and the assignments. So if you feel confident enough to be able to do the quizzes and assignments, by all means, focus on that. I know it's home stretch. You're probably exhausted. Some of you are a little backed up. I get it. So just keep that in mind. I can see that you're on the LMS, and that's how I've been taking the attendance. So it's not a huge deal. So I'm clearing this. I'm going to stop. I hope you have a great day, guys.